Okay, this video is for review 8 over graphing two variable inequalities. So problem 1 asks us to graph 6x plus 2y is greater than negative 14. Before I can graph, I need to solve for y. I start solving for y by moving x to the other side by doing the opposite operation so that it will cancel on the left side and move to the right side. I remember that x and numbers are not the same, so I simply rewrite. From here, I divide everything by 2 because that's the number in front of y. So y is greater than negative 3x minus 7. That minus 7 is where I'm going to start on the y-axis, so I go down to 7. And then a slope of negative 3 means I'm going to go down 3 right 1. So down 3 right 1. I can also go up and to the left. My inequality tells me that I'm going to have a dashed line because there's no line under the inequality. And y is greater than negative 7. Greater than negative 7 goes up. Anything bigger than negative 7, so anything like 0 or a whole number, would be greater than negative 7, so my shading goes above the line. Problem 2, we have to solve for y again, so I move x to the other side through the opposite operation. And then to continue solving for y, I divide everything by 5. So y is less than negative 1/5 x plus 5. Remember that if you have a negative 1, you divide it by 5 and it does not work out nicely, leave it as a fraction. Don't let it cancel. Don't let it disappear. You just rewrite it as a fraction. So the plus 5 is where I'm going to start on the y-axis, so I go up to 5. My slope is a negative 1/5, so I'm going to go down 1 right 5, down 1 right 5. My inequality is a single one. It doesn't have a line underneath it, so it's going to be dashed. And y is less than 5. Having $0 is less than having $5. So where the 0 is where I'm going to make sure I shade. So my dashed line here. And then less than 5, less than is lower than. So anything lower on the graph than my y-intercept going all the way up to that line would suffice. For the last problem, I have two inequalities here. The first one I cannot graph until I solve, so I'm going to rewrite it down here and solve for y. So I move 4x to the other side through the opposite operation. And then divide everything by a negative 3. Because I have divided by a negative 3 here and here and here, I have to flip my sign. Negative divided by negative is positive. Negative divided by negative is positive. This line has a line, or this inequality symbol has a line underneath, so it will be a solid line. Y is greater than or equal to 3, greater than we shade above the 3. So I'm going to go to 3 on my y-axis. My slope is up 4 right 3. It's a solid line. And above 3 on the y-axis, above the y-axis, would also be considered above my line. The second equation is already graphed or already solved for y for us, so we just have to graph it. This one also starts at 3, so they're starting at the same place. This one will be a dashed line because there's no line under the inequality, and y is less than 3. Less than would be the same thing as lower. So for my line, I go up 2 right 1, up 2 right 1, up 2 right 1. It is a dashed line, so I make sure to leave some space. And shading lower than would be underneath. So the only part that these two have in common is this tiny little triangle up in here. That is the only space where my green line matches the black line. Problem 4 asks me to graph x plus 3 is less than negative 1. First thing I need to do is solve for x, so I move the 3 to the other side. Negative 1 minus 3 is a negative 4. To graph, this is going to be a VUX. It's a very special case because it only has one letter. It has the letter X, that's how I know to use VUX. The V in VUX tells me it is a vertical line. So I go to where X is negative 4. This one is going to be dashed because there's no line under the inequality. So a dashed vertical line. And less than negative 4 is anything bigger negatives. So less than negative 4, if you have less money than owing me $4, you're going to owe me more money, so we go towards the negatives. Problem 5 is similar. We solve for y by moving the 6 to the other side. And then this one is a hoi, because it has the y, I know to use hoi. Hoi meaning horizontal. This is going to be a solid line because there's a line under the inequality. So we go up to 6 on the y-axis, draw a solid horizontal line, and y is everything less than 6, so using the y-axis less than 6, a number could be 5, 4, 3, 2, 1, 0, so anything underneath lower than is less than, lower than is less than, so lower than that line. Problem 6, they give us if x4 is a solution, then what is the value of x? So what they are giving me here is a value for y. And so I'm going to plug 4 in for y, substituting in, and I'm going to solve for x. So 3 times 4 is 8. Solve for x by subtracting 8 from both sides. 20 minus 8 is 12. Divide by 3, and x equals 4. For the next one, this time they're giving me an x point of 5, so instead of x, I'm going to replace x with 5. Two times 5 is 10. And then I'm going to subtract 10 from both sides, so negative 4y equals a positive 20. Divide by negative 4, and y equals negative 5. Now, something else that I've seen my students do is solve both of your original equations, solve for y, and then go look at your table, solve for y, and go look at your table. That works as well. It's just more rearranging. 8 asks me to take this graph and answer the following. The y-intercept crosses downward. I'm going to use the line instead of the points. So it crosses at negative 3. My slope goes from point to point, so I will use the points for these. My slope goes down 1, 2, 3, and to the right 2. So negative 3 halves. Also, when I back out, I can remind myself that this is a negative line, so my slope needs to be negative. So my equation is going to be y equals negative 3 halves x minus 3. Number 9, they asked me to write the equation of the graph shown. So I start at 1, so my b value is 1. For my m value, I'm going to try to find another nice point, and I believe I have one here. So I can go for your copy, you're going to need to start with this point. So for my slope, I go up 3 and to the right 2. So my equation, y equals 3 halves x plus 1. A vertical line, we would use a VUX. The slope is the u for undefined. A horizontal line is a hoi. The slope for that is 0. The rate of change for the line shown, we just count from point to point. Remember that we start with the left point and move to the right point. So we go down 1, 2, 3, 4, 5. And to the right, 1, 2, 3, 4. So negative 5 over 4. I could automatically cross out A and B because they are not negative slopes. And then I just have to determine if I'm going down 5, right 4, or down 4, right 5. For problem 13, the y-intercept, I'm going to solve for y. So I move x to the other side. So negative 2y equals negative 3x plus 8. Divide everything by that negative 2. So y equals 3 halves x minus 4. The question asked me for the y-intercept, which is the number that follows. And I write it as the point, 0, negative 4. 14, I need to do something similar, but this time they're asking me for the slope. I'm still needing to solve for y, so I move x to the other side. 2y equals negative 4x minus 10. Divide everything by that 2. Y equals negative 2x minus 5. And then their question was about the slope. The slope is with x, so my slope is a negative 2. Problem 15 asked me to graph the inequality y is less than 2x. Remember, if not having a b value throws you off, you can add a plus 0, which reminds me to start at 0. My slope is going to be 2 over 1, so up 2, right 1, up 2, right 1. This is going to be a dashed line because there's no line under the inequality. So make sure in your drawing you can make it very clear that it is dashed or that you write dashed out to the side. And y is less than 0, less than is lower than 0. So less than goes underneath. And remember, we're just using that y-axis to figure out what less than and greater than are. So if I start at 0, less than 0 is negatives. Those go down, so I shade down. Problem 16, graph y is less than x plus 4, and then it asks me which coordinate point represents the solution. So I start up at 4. I have a slope of x, which is up 1, right 1, up 1, right 1. This line is going to be dashed. And then for my shading, y is less than 4 on the y-axis. 3, 2, and 1 are less than, so wherever I shaded on the y-axis is where I would shade on my line as well. For my points, negative 8, 2 is out here. That is not in my shaded area. 2, 0 is, 2, 0 is in here. That one is in my shaded area. Negative 2, 2, C is on the line, but because the line is not included, that's not my answer. And D, 0, 6 is up here, not in my shaded area. So remember, for these, you are looking for one point that is very clearly in your shaded area. No ifs, ands, buts, doubts about it. It is very clearly in your shaded area. Problem 17 asks me to write an equation and graph the linear function. That includes the points 2, negative 6, and negative 1, 3. So 2, negative 6, negative 1, 3. So for this, I will use stat edit because I have 2 points. So stat enter. And I'm typing 2, negative 1, so my x's and my y's. Stat calc 4. And I get y equals negative 3x plus 0. So to graph, I start at 0, and I go down 3, right 1, down 3, right 1, down 3, right 1. Because this has an equal sign, it is not new material, it's not an inequality. We just graph a normal line with no shading. So an equal sign is like a normal line where it's solid all the way through, it does not change, and we do not shade. However, problem 18 is an inequality where we would need to shade. In order to shade, I need to solve for y first, so I move the 4x to the other side. And and I'm very careful with my negatives to make sure I don't lose anything. I simply rewrite the negative 4x and the negative 12, and then I divide everything by negative 3. Because I divided by a negative, my sign flips. And I'm graphing y is greater than or equal to 4/3 x plus 4. The plus 4 tells me where to start on the y-axis. I go up to 4. And then my slope is 4/3, so I go up 4, right 3. This is going to be a solid line because there's a line under my inequality. And y is greater than or equal to 4. If you have $4, you would have more dollars if you had 10. 10 is up at the top, so I shade from the top down to my line. $19 asks me which inequality is represented by this graph. I can see that my graph starts at 2, but unfortunately all of my answer choices start at 2. I can see that my line is negative, but unfortunately all of my slopes are negative. I can see that my line is dashed, but unfortunately all of my inequalities are dashed. So I'm going to need to find my slope and my shading. Okay, so my slope, if I start at my y-intercept and go to my x-intercept, I'm going down to right 3. So I could mark out C and D because those are not going down to right 3. My shading starts at 2 and goes up. So it's getting bigger or greater than 2. A greater than sign looks like this, so B would be my correct answer. Problem 20 asks me the same thing. They all start down at -1. They all have the same slope. So one thing I notice immediately here is my signs. One of them has a line and one of them does not. So I go and look at my picture. My picture has a filled in line. So I could mark out A and D because A and D would need to be dashed. And then I need to see where my shading is because my slope is exactly the same. The only thing that's changing the only thing changing from B to C is my shading. So this one starts at -1 and goes lower or underneath. Another word for lower is less than. Remember that for an L for less than, if you circle it and you make it just a little bit like that, that is a less than sign. So C would be a less than sign. 21 is a review. It asks us which of these are a function. Remember, a function means x's don't repeat. On 1, 3 repeats. 2, they are all different. 3, x repeats. 4, they are all different. So 2 and 4 are my options that are not repeating. All right, 22 through 25 are asking me to match based on graphs. So when I'm looking at my graphs, something I can immediately see is that this one starts at 1, where all the rest of them start at 3. So G is going to be 22 because it's the only one that has a +1. I'm going to try to look for differences here. So on 24, this one's going to have a much steeper, or I'm sorry, it's going to have a negative slope. Oh, sorry, we've already marked out G. Sorry, I was trying to look between G and J. So, looking at negative slopes, F has a positive, H has a positive. The only one that has a negative is J. So now I'm looking between F and H. These both start at 3. These both have the same shading. I'm just looking at the slopes now. So F is going up 1, right 4. H is going up 4, right 1. So F is up 1, right 4. H is up 4, right 1. So slope of 4 would be 25. Slope of 1/4 would be 0.25. Sorry, slope of 4 would be H. Slope of 1/4 would be 0.25, which is F. Just a couple more problems here. 26, we have 3 inequalities that we need to graph. This is a special case. It's a HOI, and it's going to be solid. So I go up to 4. I draw a solid horizontal line. Y is less than 4. Less than 4 means lower than 4, so I shade underneath. Another HOI. This one is going to be a dashed line. I go up to 1, and I do a dashed line. This time Y is greater than 1, so I go above my line. And then I have a bucks to finish it off. I go to -3 on the X. This is going to be a solid line, a solid vertical line because it's a bucks. And X is greater than -3, so I shade towards the greater than side, which would be anything on the right of my line. And the only part where they overlap is this rectangle in here. That would be my solution area. So if you want to color it a different color, a darker color, make sure it's darker, whatever, but make sure it's very visible to see which one. 27 has 2 special cases. Both of these lines are going to be dashed, and both of them are going to be vuxes. So for the first one, we start at 3. It is a dashed vertical line, so I go up and down, leaving spaces in my line. X is less than 3. Less than 3 would be 2, 1, 0, anything that is negative, so I go to the left. And then X is greater than -2. This is another dashed line, so I go over to where X is -2, and I draw a dashed line, leaving some spaces. Greater than -2 goes to the right because anything bigger than 2, like a whole number, would be a solution. And this middle rectangle would be my solution set in here. So make sure that middle area is darker or more obvious, a different color or something like that. 28, 28, we have 2 different inequalities here. So I need to solve for Y first before I can graph. I move X to the other side, and Y is greater than -X plus 3. I go up to 3. My slope is a -X, so down 1, right 1. This is a dashed line. And Y is greater than 3. Greater than 3 would be like 10. 10 is up at the top, so I shade up to the top. My other line also needs to be solved, so I move the 4x to the other side. Y is less than -4x plus 4, and because Y is by itself, now I can graph. So I go up to 4, and then I go down 4, right 1, down 4, right 1. This is also a dashed line. Y is less than 4. Less than means lower than, so we shade underneath the 4. Underneath the 4 would be down on the y-axis. And my solution set is this triangle in here where my colors overlap. For problem 29, I need to solve this one for x. So I add 4 to both sides. X is less than or equal to 2. This is a bucks for a special case. So I go over to 2 on the x-axis. We have a solid line because of the inequality. And it's vertical because it's a bucks. X is less than 2. Less than 2 would be 1, 0, anything that is negative. And then for the second equation, we solve for y. Y is greater than -x. Remember, you can put a plus 0, so you remember where to start. -x means down 1, right 1. This is also a solid line. And y is greater than 0. Greater than goes above 0. So up on the top. And my solution set is this triangle up at the top. Okay, for K1, this is a Bucks. So that's going to be x equals a 2. K2 is a Hoy at 3, so y equals 3. K3 starts at 0 and goes down 1, right 2, so negative 1/2 x. Sorry, it goes 3. I apologize. 1, 2, 3. So negative 1/3 x. And then the last one, the parent function of this graph, this is a line, so our basic parent function is y equals x because that is the basic equation of a line.